are asking me about the derivative and whether it's right or not. Admittedly, it looks a little gross. So just to nudge you all away, I'm not going to finish the question, but let's just do the derivative together and see if you can check your answer whether it's right or not. Now, you got two things to notice here. Number one, it's a product. It's this times that. Okay. But number two, one of the factors of your product requires chain rule, right? Namely this one. Okay. To make that a little more obvious, remember that sine cubed x is just kind of our shorthand for saying sine x all cubed. Right? Do you remember why we do that, by the way? Why do we put the 3 in the middle? Because that's weird. Yeah, good. So that you don't call it this. Sine of just x cubed, which is its own function, right? And you deal with that another time. So therefore, if that's sine x all cubed, how are we going to do this? All right? This is u, this is v. Let's give this a go. You test on your own working and see if this checks out. Okay? Just for the sake of making sure your answers are right, let's do u, work out its derivative, because we're going to need it for product rule, right? Let's do it on its own. So I want to work out the u on the x. Is that okay? Right. Now this is sine x all cubed, so forget the fact that it's a trig function, right? Just call that f of x, f, okay? If this is f cubed, and you're doing chain rule on it, right? Chain rule is you differentiate the inside, differentiate the outside. Right? Inside, outside. What's the inside here? What's the f? It's sine, right? So therefore f dash, the derivative of the inside, is cosine. Yes? There's the inside, now you do the outside. It's to the power of 3, so you bring the power out the front and reduce the power by 1. Okay, so if you're following along, right, this is the u dash that I'm after. Okay, so I'm going to keep that in mind. And now I'm going to write my v u dash plus u v dash. Okay, this is just useful so you don't get your head too twisted. I know some of you were doing this part, but because you're doing it in line here, for instance, you might have forgot to put an extra cos on from your v, right? So let's give this a go. V is cos. U dash is this guy, right? So I've got a cos there, cos here, so cos squared. There's a 3 out the front. There's v u dash. So far so good? U is unchanged. And then v dash, cos turns into negative sine. Right? Okay. Happy? So you got sine of the 4 here, sine of the 4. I can take that out as a common factor, because there's sine squared here, so I can take that out the front. Okay, now there's your derivative. So at this point you can know whether you're right or not, because I think most of you have either this line or something different. Now, I'm actually not going to stop there. I want my derivative to be as simple as possible, because in a minute I'm going to have to solve it so I can find stationary points. Yeah. So how can I improve this? Well, I've got all these trig functions flying around. I've got a lot of them, right? So I'm going to try and eliminate some. Now, remember, cos squared and sine squared, they're almost, sort of, interchangeable in that you can use the Pythagorean relationship to sub one out for the other if you want to get rid of one, right? By the way, you don't have to. You can do tan squared later on if you want. That's perfectly legitimate. But this is just one way to simplify, heads up. Okay? So you can either get rid of cos squared and turn it into 1 minus sine squared, or you can get rid of sine squared and turn it into 1 minus cos squared. Which do you think we should go with? Does it matter?
Not really.
It doesn't really matter, because like I said, right, sine squared, cos squared, they're sort of interchangeable. So whichever you go with should be okay. I'll tell you which one I'm going to do. It's almost 50-50. I'm going to get rid of the cos. Okay. The reason why, I'll tell you, it's simple, is just because of that negative sign. That's it, right? The number of people I've seen write for the next line, right? If they were getting rid of sine squared and subbing out for 1 minus cos squared, right? They'll write 3 cos squared, and then they'll write minus 1 minus cos squared. Okay, so they miss the double negative. And it's a very easy error to not pick up. Okay, so I just try and avoid double negatives. That's why I'm going to get rid of it. Okay. So therefore, my next line will be sine squared 3 minus 3 sine squared.
This means there are a lot of stationary points.
Okay, so there's my derivative, and I think I'm happy with how simple that is. Okay. Now, if I want to solve this, right? If I want to graph it, I'm going to need to find stationary points from this. I won't make you do points of inflection for obvious reasons, okay? But even so, without doing second derivative, you can see, looking at this thing, it's going to have a lot of solutions, okay? There are a lot of stationary points to this thing, okay? So I'm going to pause there, because now you know whether you got the right derivative or not, and then let you have a go at graphing it.